Hello students, today we will be discussing few numericals based upon ray optics. In ray optics we know about the various formulas which can be used, that is mirror formula, lens formula and the formulas which are based upon the apparent depth, real depth including the refractive index. So our foremost question, an object is placed in the front of a convex mirror at a distance of 50 centimeter. A plane mirror is introduced converging converging the lower half of a convex mirror. If distance between the object if the distance between the object and the plane mirror is 50 centimeter, it is found no parallax between the image formed by the two mirrors. What is the capital R of convex mirror? Now, in this question, capital R of convex mirror means that we have to evaluate its radius of curvature. Now, if I draw its figure, the question means that there is a convex mirror. This type of convex mirror is there. This type of convex mirror is there, and it is said that in its lower half we have placed an plane mirror. It means like such a way we have placed a plane mirror over it. Now it is said to us that we have we have an object O. Let an object be here, that is the place of an object. Now it is said that at distance of 50 centimeter in front of a convex mirror, object O is placed. So it means the distance between O and the convex mirror is 50 centimeter. Now it is also said that there is no parallax between the images which is formed by the two mirrors. So the image formed by the mirror will be in such a manner. Like if the ray of light is incident on the principal axis, then it will be retrace its own path. Now, if a light is moving in this manner, means this is an incident light, it will be reflected and this is a normal over it. Let it mark it as C. Now, if it is a angle of incidence, then the reflected light will be at the same angle, that is angle R. This is reflected light and this is angle R. So we can say that we have an image by extending it backward. So we have an image at point I because the two rays are meeting at this point. Okay. Now we want the R of this. To calculate the R of this, what we do is we know about the plane mirror that distance of object from a mirror is equal to distance of image. We know about it. Now, after this, what we do means now we know about that we have, let us mark it as point M where the plane mirror is kept. Okay. Now, on marking it M, we know that PI, let it mark it P as a pole. Okay. Now, in the figure, we know that MO means distance of object is equal to MI, that is distance of image. Now, we want PI. So, for PI, we know it will be MO minus MP. So, it will be 10 centimeter. Now we have a PI. Now this was all about the plane mirror. Now let us deal with convex mirror. For convex mirror, if we talk of a convex mirror, we know that U, that is distance of object, is minus 50 centimeter, and we know about V, that is image distance, is plus 10 centimeter. By using the mirror formula, that is 1 over F equals to 1 over V plus 1 over U, we can evaluate the value of F. So, substituting the value of UV, that is 1 over V, that is 10, plus 1 over U, that is 1 over 50. That will give you, on solving us, that will give us 2 by 25. This 2 by 25 is a value of 1 over F. It implies that F is 25 by 2 centimeter. But we didn't want the F, we want the R. But R is twice of F. So it means 2 into 25 over 2 centimeter is equals to R. That is 25 of centimeter. So we can say that radius of curvature of the convex mirror used above is of 25 centimeters. Let us discuss another question. Another question is based upon the real depth and the apparent depth. Is filled with water to a height of 12.5 centimeter. The apparent of a needle lying at the bottom of the tank is 9.4 centimeter. Find refractive index of water. If water is replaced by a liquid of refractive index 1.63 up to the same height, what distance what distance would the needle again be focused? Now this is our question. In this question, we are said that there is a tank which is having a water up to some height, and there is a needle which is lying at the bottom of the tank. We are given the apparent depth. We have to evaluate the refractive index of water. Same question is repeated, but in that particular question, we are given the refractive index because water is being replaced by some liquid. So we are known about the refractive index of liquid. Now we want to evaluate the apparent depth, means at what height will it appear to us, means the needle will appear to us. So starting with this question we very well know that refractive index in terms of apparent depth and real depth is equals to real depth over apparent depth. Now first we want the refractive index of water. So mu will be equal to real depth. Real depth is given to us 12.5 while the apparent depth is given to us as 9.4. On dividing it we will be getting 1.33. So 1.33 is the refractive index of water. Now solving this question in case of liquid. When we talk of a liquid, in this case we have mu is equal to 1 over 6.3. Now it is said to us that the needle won't be removed, or we can say that it is not given to us that the needle will change its position. It means that the real depth in both the cases is same. So real depth is 12.5 centimeter because the height of the liquid will remain the same. So mu is equals to real depth upon apparent depth. Real depth is, mu is 1.63, real depth is 12.5, let apparent depth be x. So on solving it, we will be getting x equals to 12.5 over 1.63. It means x equals to 7.7 centimeter. So this is the apparent depth in case of a liquid. So we can say that the distance through which it has been moved can be also calculated, that is by subtracting 9.4 from 7.7, that is 1.7 centimeter is a distance moved, or we can say that it is a distance through which the needle have been moved for us. Okay, thank you students.